Okay, I am back again doing another little review, and here we are just reviewing that a slope on a position time graph, a steeper slope is going to be faster and a shallow slope will be slower. This is because the steep slope means that they got all the way up to this position, so way far away from where they started, in less time. Whereas this slow slope, they only got about half as far and it took them longer. So the steeper slopes are faster and the shallow slopes are slower. Okay, again, this is just saying that again, a steeper line is a faster speed. Yeah. Okay, this is a perfect kind of a summary of the position time graphs that we've been looking at. We have a fast, steady speed going up. We have a steady speed at a slower pace over here. Then they are stopped. They are not moving because their position is not changing. And then here their position is decreasing. So they are getting closer and closer back to where they started from. All right. The only place that acceleration is shown on this graph is on the blue line. Okay, the curved blue line is showing us that they're getting faster, which is acceleration. And you can see that because if you look down here, it took about, let's say that time is in seconds, it took about 3 seconds to get 1 unit of distance. Let's call them meters. So they only went 1 meter in about 3 seconds. And then up here on this same blue line, in 1 second, right, from here to here, they're going 2 meters. So they are twice as fast at the end of this line compared to the beginning. Whereas these lines are a constant speed the entire time. All right, so only acceleration is the curved line on a position time graph. Otherwise, steep slopes are fast, shallow slopes are slow. Horizontal lines are stopped. And what we haven't looked at yet is the negative aspect. Okay, so over here on this side of the page, this is position 0. Down here, this negative line is going to be moving backwards behind position 0. And because it is at a steep slope, they're moving fast. Down here the position doesn't change, and here they're going back towards position 0 but more slowly. And then they keep going past that, again even slower, out to ending at about position 14. Okay, so the negative aspect here on a position time graph, all that means is that you are behind position 0. If position 0 is the end of my front desk, like I was usually using it, and the top half of this graph is anywhere that is between the desk and the coffee maker, and the negative part of this graph is anywhere between the desk and the door into the classroom or the fume hood. All right. Okay, so going into our velocity graphs a little bit, this is still a position time graph, but anywhere that the position is increasing away from position 0 is going to be a positive velocity, which means on a velocity graph, it's going to be up here above the x-axis. So if we have sorry, trying to make this smaller. On this position graph, anywhere that the line is going up, it's an increasing positive velocity. We are going to see that anywhere above the x-axis in the flat line is still going to be, this is going to be a diagonal line on the position graph because it's a constant speed. These diagonal lines on the velocity graph, because they are acceleration, they would be curved on this graph, but they would be position increasing. Okay. Here we have a stopped, again, a position graph, distance is not changing. and then negative velocity. This is where it gets a little tricky. So negative velocity, because they're going, sorry, I'm blowing up here. Let me turn off my phone. Send it to the front office. I'll get it back after 7th period. Okay, so as they're going down here, this is negative velocity because their position is decreasing. Okay, so this part right here, this negative slope, is going to be shown on a velocity graph as below the x-axis. All right, negative velocity because you are going back towards position 0. You can see that this car is turned backwards because this symbolizes he's going back towards where he started. Not back in time on the graph. This would be a separate thing, but negative velocity, he is going back towards position 0. On here, a negative velocity is going to be anything below the line. You are going back towards position 0. Okay, so just as the slope of a position time graph reveals velocity or speed, the slope of a velocity time graph reveals acceleration. All right, so on this position time graph, these slopes are constant speed, faster, slower, in between. Okay, up here on this velocity time graph, the slopes are acceleration. And this steepness has to do with how fast or slow you're accelerating. This is what we're going to be learning about next week. Basically, this slower acceleration is you getting on the freeway on-ramp when you're not in a rush and there's no other cars, and you're just slowly speeding up to 60 miles an hour. This steep line of acceleration would be something like getting on the freeway on-ramp and there's that car right next to you and you want to beat them, and so you are accelerating much faster, increasing your speed at a much faster rate. So steepness means something different on each graph. Okay, as you're watching this video, like get out your stuff from class and take notes. Don't just listen to me talk, but take notes, write stuff down, go back and watch it again, all of that good fun stuff. All right, so velocity time graphs now. Now we are no longer talking about position or distance over here. We're talking about velocity, which is speed. So these graphs are not measuring how does your position change relative to where you start. They're measuring how fast you're going, all right? So if you're just sitting by a campfire at a tent and you're not moving, then your velocity time graph is going to be a straight line all along the x-axis because you have a velocity of 0, which means stopped. Time is still passing, so you just are sitting there with a velocity of 0. That is what my graph looks like right now. I'm sitting on my couch talking to my computer, and this is my velocity graph. Okay, if you are out running around the track, let's say you're doing the mile or the 2 mile in PE, and you pretty much are running the same exact speed for the whole mile, then your velocity graph would look like this, but because you are staying at a constant speed, all right? If you're driving down the freeway and you have cruise control on, this is exactly what your graph would look like. If you ever have cruise control on a car, then it would be a perfect constant speed. Okay. And then anytime your velocity is changing, you have to speed up to pass someone, you have to slow down because you're getting to a red light. You speed up because you're going from the 700 building to the 100 building, you slow down because you don't want to go to your next class. That's going to be your different accelerations, different velocity time graphs with diagonal lines. Okay, so here we have an example of a velocity time graph, and this is for like riding a quad would be the example. So he didn't start here on this graph from a velocity of 0. They started from a velocity of -2, and that just means that wherever they decided position 0 was, that he starts out moving back towards it. So let's say position 0 is like this, the finish line, okay? So he's getting faster right here because this would be like a speed of 20 and this would be a speed of 10. So his speed would increase from -10 to -20. Negative just because he is going back towards position 0. That might sound weird. Let's look back at our other graph. Negative velocity right here, this part of the graph, because they're going back towards position 0. Okay. So he's in position 0. We are calling the finish line. He is accelerating, and now he is at a constant speed. Okay, constant speed driving, again, still towards the finish line. This is going to be like -20 something. Right here, maybe there's another quad he's trying to pass to win the race, so he accelerates up to an even higher speed. Maybe this could be a gear shift as well. So now he's going super, super fast towards the finish line, which is position 0, which is a negative velocity because you're going back towards position 0 instead of away. And then all of a sudden he starts to slow down. So maybe something's wrong with the quad, okay, because he is slowing down and it's a race, so who knows, because his velocity is decreasing. Out here he's out at 30 meters per second. That's really slow for a quad, but he's at 30 meters per second. Now he goes down to 20. Now he goes down to 10. So he's slowing down here. Probably what it is a really sharp turn, okay, and he knows if he takes it fast he's going to roll. So right here, right when he crosses this velocity 0 and goes from a negative velocity to a positive velocity, he turned around there, all right? So he slowed down, turned around. Now he's in positive velocity, which means he's going away from position 0. So maybe that finish line was on a curve or something. Away from position 0, accelerating, his speed is getting up, and now finally he is at a constant speed. Okay, so that would be a velocity time graph, very different than a position time graph. Okay, on this graph here we have acceleration, we have constant speed, acceleration, constant speed, acceleration, turn a corner right here, acceleration and constant speed. All this stuff down here is moving towards position 0. All this stuff up here is moving away. Again, positive velocity is all this part moving away from position 0. Negative velocity, all this part moving towards position 0. Okay. I think that is where I'm going to leave you with that review. Again, I recommend a great way to study as just, getting out these notes that we did on Friday and labeling, what does a horizontal line mean? Does it mean anything different on a position time graph if it's above and below the x-axis? What did the different steepnesses of the lines mean? Really kind of compare and contrast this velocity time and this position time graph. Draw a bunch of them up with a friend or with a sibling or a parent and see if you can walk in the motion the right way, or if your friend can walk in the motion the right way, and then you can correct them as you're studying. So lots of ways for you to study and practice this weekend. Maybe not today because you're busy with Halloween, but tomorrow when you have all that sugar high energy and you don't know what to do with it, you can run a bunch of position time graphs back and forth and work off all that sugar. So I hope you guys are having a great weekend, and good luck studying, good luck on the quiz on Monday. Happy Halloween.